We're now moving on to big 5, number 2. Displacement is equal to velocity initial times time plus 1/2 acceleration times time squared. So if an object with an initial velocity of 2.5 meters per second experiences an acceleration of 2 meters per second for 5 seconds, what is the object's displacement? You'll note that this particular equation does not have final velocity in it. So our initial velocity is given to us, so our VO is going to be 2.5 meters per second. Our acceleration is going to be 2 meters per second squared, and then our time is going to be 5 seconds. We plug this into our formula, and we know that our displacement is going to be equal to our initial velocity, which is 2.5, times our time, which is 5, plus 1/2 acceleration, which is 2, times our time, which is 5, and then squared. Delta S is going to be equal to 2.5 times 5. We put that into our calculator, and that comes out to be 12.5, plus 1/2 times 2, which is going to be equal to 1, times 5 squared, which is 25. Obviously, 1 times 25 is going to be equal to 25. So 12.5 plus 25 comes out to be a displacement of 37.8, and that's going to be meters. For problem 27, we're talking about Mr. Linz while playing baseball. So Mr. Linz was playing baseball during the Caddo Area staff softball game, and when he hit the ball, go Mr. Linz, it accelerated at a rate of, when he hit the ball, I read that question wrong. If he accelerated at a rate of 1.5 meters per second squared, and it took him 2 seconds to reach first base, how far was first base from home plate? It may not be directly obvious here, but we are given 3 quantities. The first of which is our acceleration, which is 1.5 meters per second squared. The second is the time, our time being 2 seconds. Now, if we're talking about him going from home base to first base, we know that his initial velocity, his VO, is going to be from rest. Even though it doesn't say it in the problem, we can figure that out based off of context clues. So 0 meters per second is his initial velocity. Our delta S is going to be equal to our initial velocity, 0, times our time, 2, plus 1/2 over our acceleration, 1.5, times our time, 2, squared. Delta S, we bring this down, 0 times 2 comes out to be 0, so we can get rid of that part of the equation. 1/2 times 1.5 comes out to be 0.75, which I could have easily have done in my head, but it's been a long day. 2 squared is going to be 4. 0.75 times 4 comes out to be a displacement of 3 meters. Very small baseball field.